going to show you how to solve Leetcode question, balance the binary tree. It's an easy Leetcode question. So give a binary tree, determine if it's height based. If it is height based, for this problem, a high balanced binary tree is defined as a binary tree in which the left and right subtree of every node differ in height by no more than 1. So if you take a look at the example here, and the left node and right node, right subtree's height is differed no by 1, and so the this level of the height binary tree is 1, right? This is 2, and this one is 1, and deferred, in this case, the difference between them is no more than 1. The difference is 1, right? And then if you look at this example, the left tree and the right tree, if you just look at this one and left tree, you can see the height difference is definitely more than 1. It could be equal than 1, but cannot be more than 1. That's why this one returns false. And if this is an empty tree, then the left subtree and right subtree difference is basically 0 also. So in this case, you want to return true in this case. So there are some constraints here. And if you look at it, although it's an easy question, but it's really good to practice on. And it was asked by Amazon, Spotify 3 times in the last 6 months. So if you look at this tree, a lot of tree problem can be solved right recursively. And this, I think one thing important is that you can write a function to basically calculate the height first, and then once you have a function to calculate the height, and then you want to write the code to call this function to calculate the left subtree, to calculate the absolute value of the left tree minus right tree, to make sure they're smaller than 2, because they are allowed to equal but no more than 1, right? So you want to make sure they're smaller than 2. And then basically, if you want to do this recursively, is that you want to continue to call this is balanced function to make sure the left subtree and the right subtree, they are balanced, to call this recursively, so that you will be able to in the end return all 3 requirement is true. Is that for the root node, you want to calculate the left node and right node's height balance, make sure they meet the requirement, and then you want to check the recursively to check the left subtrees if they are balanced, and the right subtree if it's balanced as well. And if 3 of them return true, and then this function is balanced, it will return true in this case. And then you can see the tree nodes, they all defined for you, so you don't have to worry about defining the tree and implement the tree in this case. So let me show you how to do this in code. So I'm going to just write a function to define how to calculate the height of the tree node. So generally speaking, if you want to, there's an easy Leetcode question how you calculate the tree node and the height of a tree. So this node, if you look at it, the left child and the right child is all empty, right? So it's the height is 0 of its child, and if it's 0, this tree height is 1. You always 1 plus the max of either the left tree or the right tree max. That's the height. So this is 1, and then this tree height is 2, because the left child is 1, right child height is 1. So the max, the height of this guy is 1 plus their max is 1. So 1 plus 1 equals 2, right? So for this node 3, and the max height is left node and the right node's max, and you can see this one is 2. So because right tree is bigger, so you want a 2 plus 1. So in this case, this root node's height is 3, right? So define the height of the tree. So we want to rule out the edge cases. If not root, we just gonna return 0 in this case because it's basically nothing. And then we want to return the tree height is basically 1 plus, like I mentioned to you, 1 plus max of the height of root dot left, and then you can call this recursively height root dot right. So that's basically the calculation of the tree height that you're looking for. And once you have this, and you can go ahead to check if this tree is balanced. How you check this tree is balanced is that you can rule out one of the edge cases, like it's mentioned. If the root does not exist, then you want to it's an empty tree, so you return true in this case, right? If not root, return true in this case. So then you want to calculate the value of the you want to call the height function, right? So the height function, if I run it on the root dot left, and then if I minus height functions root dot right, it doesn't matter left minus right or right minus left, because I'm going to get the absolute value of this value. So this is basically how you do it in Python. You call the ABS absolute value of their differences, and then you want to make sure that no more than 1, right? No more than 1. It's basically this value should be smaller than 2. So I want to return this as one of, if this returns true, it will, this is one of the requirement to return true, right? And then I want to also remember I mentioned that you want to do this recursively, because not only this root value, you also have to check if the left subtree is balanced and the right subtree is balanced as well, right? So you want to AND all of them. So is balanced. Oh, you want to call this function. So you're going to have to do self dot is balanced, because you're inside a function to call this function. So root dot left, right? And then you will also want it to make sure the right subtree is balanced as well. So essentially, it will only return true when the difference is smaller than 2 and the left subtree is balanced, the right subtree is balanced, and this function will return true. So that means they are balanced tree. Yep. So if you think this is helpful, please like my video and subscribe to my channel, and give me a thumbs up, and I'll see you soon with more Leetcode questions. Bye bye.